Question number one. A body of mass m is suspended by two strings, making angles alpha and beta with the horizontal. Find the tensions in the two strings. Here, this is body whose weight will act downward, mg, and this is string 1, this is string 2. Here tension is T1, here tension is T2. This angle is alpha, so this angle will also be alpha. This is beta, this will also be beta. Now, we consider horizontal and vertical components. Since body is in equilibrium, it means there is no net force. So, horizontal component of T1 must be equal to horizontal component of T2. So, T1 cos alpha must be equal to T2 cos beta, from where we can get T2. T2 equal to T1 cos alpha upon cos beta. Now consider vertical components. So T1 sin alpha plus T2 sin beta must be equal to mg. Now we put the values here. So here we are putting value of T2. So T1 sin alpha plus, in place of T2 we write T1 cos alpha upon cos beta into sin beta equal to mg. So it will become T1 cos beta sin alpha, T1 is common, plus cos alpha sin beta will be equal to mg cos beta. So T1 will be equal to, this is formula of sin A cos B plus cos A sin B, and that becomes sin A plus B. So it will become mg cos beta divided by sin alpha plus beta. Now this value we can put here. So T2 will be equal to mg cos beta divided by sin alpha plus beta times cos alpha upon cos beta. So cos beta will cancel out, and we will get T2 equal to mg cos alpha divided by sin alpha plus beta. So this is our answer. Let's take second question. Two bodies of masses m1 and m2 are connected by a light string going over a smooth light pulley at the end of the incline. The mass m1 lies on the incline and mass m2 hangs vertically. The system is at rest. Find the angle of the incline and the force exerted by the incline on the body of mass m1. So here tension will be T. The same tension will act here. So since both bodies are at rest, so net force will be 0. So we can say T minus m2g equal to 0 or T equal to m2g. This is equation number 1. And for this, T must be equal to m1g sine theta. Now, because along incline, the force will be equal to m1g sine theta. So equating 1 and 2, we will get m2g equal to m1g sine theta, from where we get sine theta equal to m2 upon m1. We can draw a triangle for this purpose so that we can get cos theta if need be. This is theta and this is m2, this is m1. So this will be equal to m1 square minus m2 square. Now, let's consider the situation here. So at this point, there will be normal reaction due to incline, and its mass will act downward. This angle will also be theta. So this is m1g and this is m1g cos theta, and this is normal reaction. So we have to find out what is normal reaction here. So normal reaction N equal to M1G cos theta. So M1G and cos theta we can put from here. So base upon hypotenuse. So base is root of M1 square minus M2 square whole divided by M1. So either we can cancel M1 or we can take M1 inside. So let's take M1 inside. M1G root of this will go 1 minus M2 square divided by M1 square. And that is our answer. Now, let's go to next question. Next question is a bullet moving at 250 meters per second penetrates 5 centimeters into a tree limb before coming to rest. Here, at this point, velocity is 250 meters per second, and after covering distance 5 centimeters, at this point, velocity becomes 0. So we can apply formula v square equal to u square plus 2as. 0 equal to 250 square plus 2 into a into 0.05. So a will be equal to minus 250 square divided by 0.1. That will be minus 62500 divided by 0.1. So minus 625,000 meter per second square. This is acceleration. Now F equal to MA. Let's write it in magnitude. So M is 10 gram, 10 by 1000 times 625,000. 3 zeros will cancel out from here. So we will get 6250 Newton. Let's go to next question. The force on a particle of mass 10 gram is this much. 10 I cap plus 5 j cap. If it starts from rest, what would be its position at time t equal to 5 seconds? So here m equal to 0.01 kg and acceleration is given along x axis. This is force along x axis. So we can find acceleration along x axis, that would be force upon mass. So force is 10 and mass is 10 gram. 10 divided by 1000. So this will be 1000 meter per second square. Similarly, AY we can find. We take force 5 divided by mass is 10, 1000. So this will become 500 meter per second square. Now, equation of motion S equal to UT plus half AT square. Along the x-axis, it will be, since it starts from this, so 0 plus 1 by 2, acceleration 1000 times t square times 5 square. This is 500. So 25 into 500. So this will become 12500 meter. Similarly, we can evaluate y also. So 0 plus half acceleration along y-axis 500 into time is 5 square. So that will be equal to, this is 250 multiplied by 5 into 5. So this will become 625 meter. So position R equal to x I cap plus y j cap. So x is 12500 I cap plus 6250 j cap. And that is our answer. Let's go to next question. With what acceleration A should the box in the figure descend so that the block of mass and exerts a force of mg by 4 on the floor of the box? So here this is block of mass m, and its weight is acting downward mg, and due to flow there is normal reaction, and that is acting upward. So normal reaction is n. Despite that, object is moving downward with acceleration a. So we can say that mg minus n is equal to ma. Net force will be downward. Mg minus n. Mg is downward force, n is upward force, and due to net result, body is falling downward. So from here, we can get n equal to mg minus ma. But in our question, here, n equal to mg by 4. So we write it here, mg by 4 equal to mg minus ma. We can remove m and take a to LHS. A equal to g minus g by 4. So this will become 3g by 4 meter per second square if unit is SI. Thank you for watching.